Hey there, today we're going to start looking at some special factoring formulas, and the first one we're going to look at is potentially the most useful. We call it the difference of two squares, or sometimes just the difference of squares. Same thing here. Here's how it works. Let's say I start out with some expression x squared minus 4, and I want to factor this, okay? I can sort of imagine that this is equal to, well, I want to put this in the form of ax squared plus bx plus c, right? So it's sort of x squared plus 0x minus 4, right? That's what I've got here. And we know how to factor quadratic expressions just like this. We're going to find essentially the factors of -4 that add up to give us 0, right? So the factors of -4 that add up to give us 0, that's what we're looking for. Okay, now this is a negative number, so the factors of negative number, one must be positive and one must be negative to multiply and give us a negative number. So let's say this could be 1 times -4, or maybe 2 times -2. And then you could also have, I guess, -2 times 2 is the same thing, right? -1 times 4, it's very similar. Do any of these add up to give us 0? Well, this one does, right? So right here, 2 plus -2 is going to give us 0. So this must be the two numbers we're looking for. What that means is we can express this factorization as some x plus 2 times x minus 2, okay? And this should then give us the factorization for our original expression. That's good, right? This does work. You can FOIL it out. You're going to discover that it works. But you should recognize what we have here, because we've looked at multiplying two polynomials like this before, right? This is basically like the product of the sum and difference of the same terms. I think that's what we called it, right? In fact, when we looked at it before, we said you could have some a plus b multiplied by some a minus b. And what would we get? Well, we would get, essentially, if you FOIL this out, you get an a squared, right? Outer times outer would then be minus ab, and then the inner times the inner, well, that would be a plus ab, and then finally a b and a negative b, that would be a negative b squared. These two middle terms cancel out, and so we're left with some a squared minus b squared, right? And so that is what we found before. What we're doing now, instead of multiplying, getting the product of these two polynomials, is we're factoring this. We're going the other direction, right? So in order to do that, well, we just do the same thing. And so essentially what this difference of two squares rule is, it's just doing that backwards, right? So it's going to be something like this, right? Anytime you have any a squared minus b squared, you can factor that out into some a plus b multiplied by an a minus b. And that's what we have here, right? Because these are perfect squares. X squared, and we can think of 4 as a 2 squared, right? So this is, in fact, a difference of two squares, and it does come out into this form of x plus 2 times x minus 2. Let's try a few examples to sort of see how this works. So this next example here is an x squared minus 81, and I want to think of this as then x squared minus 9 squared, right? And so what our rule is telling us is that this can be written as some x plus 9 times some x minus 9, right? That should be our answer. Let's verify this by FOILing. Okay, first times first, we'll get an x squared. Next, we're going to have the outer times outer. That'll be actually a minus 9x. Inner times inner will give us a plus 9x. And then finally, 9 times negative 9 will give us a negative 81. Sure enough, these two cancel. This is x squared minus 81. And that means our formula works. Okay, let's try the next one here. I want to think of this as some a squared minus b squared, right? Some a squared minus b squared. What is a? Well, must be the square root of like this, right? So that's going to be 2x squared. And here, well, that's going to be a 7 squared, right? I can think of, just take the square root of each of these to just sort of discover what a and b are. Now that I've written it down in this form, it's very easy to see the factorization is going to be a 2x plus 7 times a 2x minus 7. And that should be it. That should be our final answer there. Okay, and if you want to go ahead and factor it out yourself, you should find that is in fact what we get. All right, so next I just want to try one last final example here. And for this one, we can do exactly what we just did, right? So we can think of this as some a squared minus b squared, right? In this case, what would that turn into? Well, a would have to be 6x, right? So we can think of this as some kind of 6x quantity squared minus, well, 64, that'd be 8, right? 8y quantity squared. So this is one way we can rewrite what we have. And once we have that, we can see this must be equal to some 6x plus 8y times 6x minus 8y, just like that. Okay, that works. However, these are not fully factored, are they? Right? I can factor a 2 out of this, and I can factor a 2 out of this. If I do that, what do I get? Well, I'm going to get essentially 2 times 3x plus 4y. And I factor a 2 out of here. I'll multiply this now by 2 times 3x minus 4y. And these two 2's I can combine together, and I see this should equal then 4 times 3x plus 4y times 3x minus 4y. Okay, and so this is actually my final factored form, just like that. And I could have actually done this a little bit differently, right? If I just grab a copy of this really quick, what I can recognize is that I actually already should be able to factor out a 4 from both of these. These share a greatest common factor of 4. So I can actually rewrite this as 4 times, well, this would be 9x squared minus, this is going to be 16y squared. Okay, so that's what I would get if I factor a 4 out of that. So really what I'm trying to do then is I can rewrite this as 4 times, this would then be a 3x quantity squared, and this would be a 4y quantity squared, like that, right? And now using my a squared minus b squared formula, I see I'm going to get then 4 times 3x plus 4y times 3x minus 4y. And this should be exactly what we got before over here, and it is. Okay, so this is the a squared minus b squared formula, the difference of two squares. We can factor that out using this very convenient formula. Like I said, this is probably going to be one of the more useful of the special factoring formulas that we know. So hopefully that helped. We're going to learn another special factoring formula in our next lesson, so I will see you there.